Okay, so the answer, the question here is to find all 6 trigonometric functions of a specified angle. The angle is negative 15 pi over 4. And it's assumed that we're going to find exact values. And again, the whole idea behind this is we find exact values when we know coordinates of angles. As the ray crosses the circle. We have this function that's up here. This is what we began the class with. If we know the coordinates of the intersection of the terminal ray of an angle in a circle, you can find all 6 trig functions. Really, I should say you can find the exact value of the functions of the angle t. As long as you know the y coordinate and the x coordinate and the radius, of course the radius is going to come from that, then all the rest should fall into place. It's just those ratios right there. And we talked about this whole unit circle thing. Talked about the hand trick and how we can figure out if an angle is coterminal, it should be on that unit circle. Now, the problem we're working with here, negative 15 pi over 4. Question is it an angle whose terminal ray is coterminal with another angle on the unit circle? Well, the answer is yes. If you look at that, negative 15 pi over 4 is not an angle that's on that unit circle. Again, we can go to that unit circle. Nowhere on there will you explicitly see negative 15 pi over 4. Nowhere on there will you see that exactly. However, if we go back, we use the method that I use. Number one, the middle finger is a pi over 4. This is like saying 15 pi over 4 units. And if we hold our hand up, the middle finger represented pi over 4. So we should know this then. We should be dealing with coordinates that are inversions of square root of 2 over 2, square root of 2 over 2. What we don't know is, are they both positive, are they both negative, is one of them negative? That comes from the negative 15 part of things. And so what I do is I know that if I start right here, I'm at no pi over 4 units. And if I go all the way around to over here, I'm at negative 4 pi over 4 units. And if I go all the way around again, I'm at negative 16 pi over 4 units. How did I do that? Well, I'm dealing with pi over 4, right? Well, I'm at 0 right here. I'm sorry, you're right, negative 8. Is that the issue? Yeah, I'm thinking of 2 times around. Negative 8. Okay, question still? Why did I pick square root of 2 over 2? Again, this goes back to, remember the hand, thumb, this is my artistic rendition, right? There's the hand right there. Here's the pinky. So the pinky is the positive x-axis, and the thumb is the positive y-axis, remember? Right? And we know these coordinates are 1, 0, and 0, 1. Those you just have to memorize. And the ring finger, I'll put a ring on there, the ring finger was in terms of pi over 6. The middle finger was in terms of pi over 4. And the index finger was in terms of pi over 3. And if you will remember, pi over 6, if we pull in, and I can't illustrate that on here, but if we were to somehow eliminate, we'll do it like this. If I was able to eliminate this finger right here, then what I have is 3 fingers above it and 1 finger below, right? So pi over 6 is always in terms of square root of 3 over 2, 1/2. Because if I pull in my ring finger, in other words, if I eliminate it, I have 3 fingers above it and 1 below it, right? You get that part? Then just, well, that just messed the whole thing up here. Pull this out here. Okay? Now, what if I eliminate this finger right here, the middle finger? Well, then I have 2 fingers above it, 2 fingers below it, don't I? Which makes pi over 4 square root of 2 over 2, square root of 2 over 2. The 2 and the 2. You see that? All right, and then the same idea, if I were to somehow eliminate the index finger and I'm left with 1 above, 3 below, so pi over 3 is 1 over 2, that's the 1 part, and then square root of 3 over 2, that's the 3 part. Okay, that's how I know that I'm dealing with square root of 2 over 2, square root of 2 over 2. So we go with that part of things. All right, I'm going to need to just erase that and get it out of the way. So let's go back to, now the question is, again, are the coordinates going to be both positive, both negative, etc., etc.? And so since I'm dealing with pi over 4 as a negative, I start there, I go 0. I go all the way here, I'll go negative 4 pi over 4s. 4 over 4 goes down to 1. All right, if I start here and go down to here, I've gone negative 2, and this is negative 6, and that's negative 8. And that's just counting off the circle right there. Now, how many pi over 4s do I need to go? 15 in the negative direction, right? So if I start here and go all the way to here, I've gone 8 of those, haven't I? Plus 2 is 10, plus another 2 is 12, plus another 2 is 14, and I need to go 15. So does it make sense I'm going to be in quadrant 1? Which means then that both x and y are positive, aren't they? Which means then that I don't need to change anything. I know my sine is the square root of 2 over 2. My cosine is the square root of 2 over 2. And then if I were to, we'll change colors here. If I were to take the cosecant, that's simply 2 divided by the square root of 2, which rationalizes just the square root of 2. Yes?
So you all the way around, you pretty much plot in a quadrant, and you go by whichever.
Yep, that's it. That's it. All right, can y'all tell that's also going to be square root of 2? Now here's the challenge. What's the tangent going to be? It's 1. Doesn't matter either way. I'm going to go by pi over 4. The negative is attached to the 15. It's 1, y'all, because what is tangent? It is the y coordinate divided by the x. Well, what is something divided by itself? 1, right? What's the cotangent going to be? Well, it's the x divided by the y, and it's still 1, isn't it? So we have the exact values of all 6 trig functions here now, based on using the hand, figuring out that pi over 4 gives us square root of 2 over 2, square root of 2 over 2. The negative 15, we worked it out. Negative 15 pi over 4 is coterminal with pi over 4. Yes? Yes, as long, yeah. As long as it's coterminal, the radius is still 1. Absolutely. In other words, we plucked it off this unit circle. We did. Yes? Are we ever going to have problems where we're going to be not on the unit circle or have a different radius? The answer to both of those questions is an unequivocal, absolute yes. Is it going to be challenging? No, because you guys are in pre-calculus. Y'all are ready for the challenge. All right. Find all 6 trig values of this. Okay, so this one here, this is in terms of pi over 7. That's in terms of pi over 7. Well, on our unit circle, all the angles we deal with are in terms of pi over 2, pi over 3, pi over 4, and pi over 6. So you can already tell that this angle right here is not an angle that's coterminal with the angles we deal with on the unit circle. That part should be pretty straightforward there. So the next question is how in the world are we going to find these values of this trig function? Because this is an angle whose terminal ray does land in a circle. As a matter of fact, this angle here will be in quadrant number 1. Now how do I know that? Well, again, quickly, I'm dealing with, in this case, pi over 7s. But if I start right here, I've gone 0 pi over 7s. If I go half a circle, I've gone 7 pi over 7s. If I go all the way around again, I've gone 14 pi over 7s. Start back from scratch, if I go quarter of a circle, that's 3.5 pi over 7s. Well, the angle's got to be 2 pi over 7s. So can y'all tell that our angle is in the first quadrant, right? You know, but what we don't know coordinates, do we? And for us to find exact values, we need to know coordinates, don't we? Well, in a case where we legitimately, now I use that word legitimately, case where we legitimately don't know coordinates, we're allowed to use our good old trusty calculator. We can use our calculator. We're allowed to do that when we legitimately don't know coordinates. Now, I say legitimately because I'm sure there's some student who goes, well, I never memorized this, so I never knew the coordinates, so I can always use the calculator. That's not true. We legitimately don't know the coordinates for where a ray making the angle 2 pi over 7 crosses a circle. So how do we find the sine of 2 pi over 7? Well, on your calculator, there is a sine button. It's about halfway up there. I'm going to press it, sine, and then I just need to do 2 pi divided by 7. And I'm going to hit enter, and I get a value there, right? Now, my question to y'all in the class who are doing this, did everyone get 0.781831485? Or did someone get something different? All right, now, so the question really is who's right? Am I right or is someone else right? You know, well, what did I just tell my calculator to do? But what I want my calculator to do is find the sine of 2 pi over 7 radians. Now, how do I know I need to find radians? Well, not because there's pi in the angle, because there is no degree sign. The degree sign's not there. There is a lack of a degree sign. We're in radians, automatically. So my calculator found the sine of 2 pi over 7, but did it read that as 2 pi over 7 radians or 2 pi over 7 degrees? How do I know? Well, that's where I've got to pay attention to this thing called the mode, and I need to look. In my calculator, and that's just my fourth line down, it says that I'm in radians, and that's what I want to be. Because had I put it in degrees instead, had I not paid attention to that and put it in degrees, then here's what would have happened. I would have taken that thing again, and I would have gotten 0.015665397, and I'd have not known any better. I'd have just written it down and gone with it because I wasn't paying attention. Remember, I told you that from now on, you're going to have to pay attention to the mode you're in. Anytime you press a sine, cosine, or tangent button on your calculator, you're going to need to know what mode you're in. We want to be in radians. Let me go back and change the radians. Okay. So we get sine of 2 pi over 7. And then the standard is to round to 4 decimal places, so that's 0.7818. So in other words, if we were to put coordinates, then that would have a radius of 1, and the y would be 0.7818, if we were able to figure that out. So how do we find the cosine? Cosine, 2 pi over 7. That's 0.6235, rounded in 4 decimal places. Yeah, these are the answers. Like I said, when the angle is legitimately not an angle in which we know the coordinates, then we can just simply use our calculators. So what about the tangent of 2 pi over 7? We get 1.2540. We go to 4 decimal places. What now? Question? Right. Brief. That's correct. In fact, what will probably happen is it'll say round answers to, that's a telltale sign right there that you use calculator. Right? Okay, now, the next question is, we found the sine, the cosine, the tangent. What about cosecant, the secant, the cotangent? Well, here's what you don't do. We know the cosecant and the sine are related. What you don't do is use this function here. What you don't do is that, because we've already learned that is an inverse. By the way, a cosecant is an inverse of a sine. But what we just pressed in the calculator by hitting second sine, what that gave us was the inverse of the sine function. That allows us to find an angle. We don't want to do that. We just simply want to find the opposite of the sine value. In other words, we know this. We know the sine was 0.7818. Isn't that what we know? Well, y'all, that's like saying this. That's like saying that the y coordinate is 0.7818 and the radius is 1. So does it make sense the cosecant is 1 divided by 0.7818? Does that make sense there? Right? So in order to find it, all we need to do then, isn't the cosecant just 1 divided by the sine of our angle? 1 divided by the sine of 2 pi over 7? 1.279. So what's the secant going to be? Isn't the secant just 1 divided by the cosine of 2 pi over 7? That's the secant, 1.6039. What's the cotangent going to be? Isn't the cotangent 1 divided by the tangent of 2 pi over 7? So really you're finding an inverse, but you're finding an inverse of the sine or cosine or tangent value, not the function. Now what do you mean by work it out?
Like, our answer needs to be 1.279, or it is 1 over 0.7.
No, it needs to be down to one decimal. I mean one number, 1.279.
Okay.
The 1 over that was how we find the value of the calculator. Yes, question.
So why did we figure out?
I was just showing you that it is an angle that crosses a circle. That's all. No, you don't need to figure out what quadrant you're in this time. Okay? Yeah, this is a lot easier because all you got to do is press buttons in the calculator. But guess what the challenge is going to be for a lot of y'all? Yeah, nothing. No challenge at all. You're not going to pay attention to the fact you need to be in radians or degrees because your previous problem was in a different one, and you're not going to figure that stuff out. And then you're going to get wrong answers. So make sure you are in the right mode. All right, so then, just very quickly, that means then that, we'll do this last one here. This is the angle 1.3. Now, is 1.3 a degree or a radian? How do you know it's a radian? There's no degree sign. Therefore, then, if I want to find the sine of 1.3, there it is. It's 0.9636. If I want to find the cosine of 1.3, there it is. If I want to find the tangent of 1.3, I got them right there. It's just simply typing it in the calculator. If I want to find the cosecant, it's 1 divided by the sine of 1.3. Again, the secant is 1 divided by the cosine of 1.3. Oh, sorry. And then the cotangent is 1 divided by the tangent of 1.3. And all I got to do is round those answers to 4 decimal places. Usually it'll tell you in the problem, round to 3 or 4 decimal places. So again, if it's an angle in which we legitimately don't know the coordinates, then we can use our calculator. Now, there's more of this stuff that we're going to do. However, as far as today is concerned, the only other thing you have is I do have a homework assignment that I want you all to work on. It's going to incorporate the stuff that we just did. It is due tomorrow for homework grade. I will let you work on it.